Hello friends, so in this video we are going to talk about properties of the fluids. We are going to cover four important properties, that is density, wet density, specific volume and specific gravity. So let's get started. Density, that is also known as mass density. So its definition is it is the ratio of mass per unit volume at standard temperature and pressure. We are using rho as a symbol for the density. So mathematically speaking, rho that is equal to m, that is mass, upon V, that is volume. So SI unit of density is kg per meter cube. So density of some common substances you can see. So air has density 1.2 kg per meter cube, wood has density 700 kg per meter cube. Likewise, water has density 1000 kg per meter cube, and mercury has density 13,600 kg per meter cube. Remember, density is an intensive property. That means it is independent on the mass. It does not depend on the mass. Although in formula we are getting mass per unit volume, but it does not depend on the mass, because for the substance, if mass increases, its volume is also increases. So what is the mass of mercury whose volume is 20 ml? Let's try to find out. For that, I do have a mercury in a beaker of volume 20 ml, and we want to find out what is the mass of this mercury. Now we know that density of mercury is 13,600 kg per meter cube. So let's try to see what is the mass of this mercury. For mercury, the density is 13,600. We want to find out the mass, and if I convert the 20 ml into meter cube, it is 20 into 10 raised to minus 6. So I'm just putting these values and try to find out the mass. So I'm getting the mass as 272 grams. Now what is the mass of water whose volume is 500 ml? Pause this video and try to find out what is the mass of water whose volume is 500 ml. I hope you have done this task. So mass of water whose volume is 500 ml is 500 grams. Now similarly, try to find out what is the density of cooking oil. Now you know, on cooking oil, its volume is written, its mass is also written. We can find out what is the density of the cooking oil. Now we can compare this density of cooking oil with density of water, whether the density of oil is less than water or it is more than water. We can find out this. Likewise, we can see in petrol or diesel station the density of petrol and diesel. Now let's try to see what is the variation of density with pressure and temperature. Although the variation of density with pressure and temperature is negligible, but in some cases it is very much important. So let's try to find out this. So as pressure increases, we know that volume decreases. So as volume decreases, density goes on increasing. Now as temperature increases, volume increases. Now as volume increases, density goes on decreasing. That means if I heat the fluid, the heated part will try to move in upward direction and colder part will try to move in downward direction. There is one exceptional case, that is water. So water has density 1000 kg per meter cube, but it is at 4 degrees centigrade. And if we increase the temperature of water beyond this 4 degrees centigrade, the density goes on decreasing. Also, if I reduce the temperature of the water below 4 degrees centigrade, also density decreases. So you can see this graph, it indicates variation of density of water with respect to temperature. We can observe as we are increasing the temperature from 0 degrees centigrade up to the 4 degrees centigrade, its density goes on increasing. Density of water is maximum at 4 degrees centigrade, that is 1000 kg per meter cube. Beyond 4 degrees centigrade, if I increase the temperature of the water, its density goes on decreasing. Now let's try to see the specific weight, that is also known as weight density. So definition wise, weight density, that is nothing but weight per unit volume. The SI unit of weight density is Newton per meter cube. Now if I convert the weight into mass into gravity, then we can write mass into gravity divided by volume. Mass upon volume, that is nothing but density. So weight density is density multiplied by gravity. So we can find out specific weight of water, that is density of water into acceleration due to gravity. So density of water is 1000 and acceleration due to gravity is 9.81. So we are getting specific weight of water as 9810 Newton per meter cube. Likewise, we can find out specific weight of different fluids. Now let's discuss specific volume. Specific volume is volume per unit mass. So its SI unit is meter cube per kg. Now we can write the specific volume as 1 divided by mass upon volume. And we know that mass upon volume, that is nothing but density. So in other way, we can say that specific volume is a reciprocal of density. Now example of specific volume, we can find out specific volume of water. It is 0.001 meter cube per kg. Now let's try to discuss specific gravity, that is also known as relative density. Specific gravity, that is the ratio of density of any fluid to the density of standard fluid. In most of cases, we are considering standard fluid as water. So we can find out specific gravity of any fluid if you know the density of that fluid. Remember, specific gravity is dimensionless property. It does not have any unit. Example, let's try to find out specific gravity of mercury. So it is nothing but density of mercury to the density of water. Now density of mercury is 13,600 and density of water is 1000. So it is 13.6. Now likewise, specific gravity of water is 1 and specific gravity of seawater is 1.2. Likewise, we can find out specific gravity of different fluids. So in this table, specific gravity of different fluids is calculated. So for air, it is 0.0012. For wood, it is 0.7. Likewise, for the cooking oil, it is in between the range 0.91 to 0.93. For water, specific gravity is 1. So likewise, for the mercury, specific gravity is 13.6. Now let's try to mix the different fluids. So first, I am adding some water. So around 40 ml water is added. Then I will add the mercury. So I have added the mercury, you can see. So mercury is at the bottom and over which water is there. Over which I will add the oil. So around 20 ml oil I have added. So here you can observe that this 3 different fluid has different densities. That's why it is separated. So the fluid which is having higher density, that is at the bottom, that is mercury, and its density is 13,600. Then over to which water is there having density 1000 kg per meter cube, and over which engine oil is there having density 700 kg per meter cube. So you can observe how the fluid behaves when they try to mix with different densities.